Hello, today we are going to look at logarithms. What are they? What do they do? Spoiler alert, they are the reverse of exponential functions. So here we go. So the setup for this is kind of the question, how can I solve an equation for x when x is in the exponent? So take a look at this first thing right here. 3 to the x equals 9. Now you probably know already what that x is, right? It's 2 because 3 squared equals 9. But let's say that I didn't know that. How do I get the x out of the exponent? Now again, that's a simple problem. You probably already know the answer. I'm just noticing this KJ right here. I don't know what that is. I don't know why I typed that. Let's ignore that. Okay, so take a look at this. This exponential equation is a lot like something we've been writing for the last few weeks, right? This is like starting amount of 120, increasing at 34%. We're setting it equal to 200, and we're going to see when does that 120, if it's increasing at 34%, become 200? Now, you had a couple ways that we could solve this over the last couple weeks. What I recommended is you graphed it. You graphed this equation, and then you graphed this equation, and we saw where they intersected. Some of you guys also did guess and check, which is great too. You would just plug in a bunch of different x's until you got it to be close to 200. So the question is, how do we actually algebraically solve for that x? We right now have no way to get the x out of the exponent. Same thing going on with this. This is like your traditional, you have $100 invested at 9% interest, compounding quarterly. How long does it take for that $100 to become $250? Again, over the last few weeks, what you've been doing is you have been graphing it or doing guess and check because we have no algebraic way to get the variable out of the exponent yet. So that's where logarithms come in. So here we go. This is the first thing on your sheet with your notes that you're following along. So this is the first thing you need to be writing. So the definition of a logarithm. What you need to know is that the inverse of an exponential function is a logarithm. So one way to say this is this. You're going to say y, this is for the definition of a logarithm. Y is equal to the, here's how you say this, log base b, this is like the little number, log base b, and then you say of x. So I'm just going to write out how you actually pronounce this. How you say this is you say log base b, the base is the little number, and then the number, the big thing, we say of x. And technically you're quote unquote taking the log of this x. Now I know a lot of you guys are probably like, what are you even talking about? Don't worry, we are going to go, the whole point of today is we are talking about what does this right here mean, okay? So if and only if, so here's what this means. Right here, what this means that some people like to think about it as like a circle of life type thing. B, so the base, this means that B raised to the y is the exponent, is equal to x. This is literally the definition of a logarithm right here, right here. So get that down, and then we'll talk about what it means. Now, notice we have to have b greater than 0 because you don't want to have a negative base of an x. You don't want to have a negative base. We want to only have a positive base. B is not equal to 1 because 1 raised to anything is equal to 1, so that's why it has to be greater than 1. And then x is greater than 0. And the reason for that is because when you raise a positive number to any exponent, whether it's positive, negative, 0, fraction, whatever, it always is equal to a positive number. So those are just your 3 stipulations. Now, if you're lost, hang in there, hang in there. Let's talk about what this means. I'm going to tell you that log base 2 of 8 is equal to 3. And here's why. It's because 2 raised to the 3rd power is equal to 8. Now, if you're thinking, how does this help me solve for a x in the exponent? Hang in there, we'll get there. The whole point right now is that this is the reverse of an exponential. The answer to a logarithm is the exponent. Think about it like that. Okay, Now that maybe you're thoroughly confused, let's break this down. Okay, so example, what is log base 5 of 625? Log base 5 of 625. What I like to do is I like to set this equal to x. Let's set this equal to x, and then let's rewrite it. What this actually means, this means that 5 raised to the x equals 625. So the question is, we're asking how many 5s need to be multiplied together to get 625. That's what log base 5 of 625 is asking. How many 5s do we need to multiply together to get 625? Now, I happen to have it on good authority that it's 4. I happen to know, if you hear my dog, that's Ursa. Ursa, it's fine. We're just doing logarithms. Okay, so 5 to the 4th is equal to 625. So what that means is that this log base 5 of 625 is equal to 4. Let's do another one. Log base 2 of 64. What does that equal? So again, let's set it equal to x. And I always recommend with these logarithms, at least at the start, that we're just going to take every log and we're going to rewrite it exponentially. So I'm going to say, okay, so 2 the base raised to the x is equal to 64. And so the question that's being asked when I say log base 2 of 64, we're saying how many 2's need to be multiplied together to get 64? What power do I need to raise 2 to get to 64? Now I happen to have it on good authority that 2 to the 6th is equal to 64. So the answer to this is 6, because 2 to the 6th power gives us 64. Okay, let's do some more. This is just two special logarithms that if you look at both of these, it doesn't have a base. So whenever, and this is a general rule, this will always be true. If you see log of x with no base, this has the implied base of 10. So if you actually look on your calculator, the two calculator buttons that you have for logs is you have just log of x and you have ln of x, and they're right on top of each other. If you're using a graphing calculator, it's right on the left side, like in the kind of the middle column of the left side. This log of x has an implied base of 10. So whenever you see this, if you want to, you can just write a little 10 in there. That's what that is. And then ln of x. ln of x is called the natural log. And that's why it has n. Don't ask me why we say ln instead of nl, but natural log. And the natural log has a base of e. So what this means log base e of x. So if you see ln of x, that means that it's got a base of e. And one way to remember that is if you look on your calculator, check it out. The ln button is right under the e to the x button. And check it out, the log button is right under, and by under I mean like you'd have to use your second button. The log button is right under the 10 to the x button. So that's a little cheat sheet of ways for you to remember that. So this is just two logarithms that they're not writing the base, but you always know, okay, so if you have log without a base written, it's automatically base 10. And if you have ln, it's automatically log base e. So just keep that in mind as we go along. We'll use some of those. Okay, so what we're going to do here is we're just going to do some practice with logs, and we're going to solve some logs to figure out what they equal, and we're going to look at some patterns and then make some general rules. So the whole point of this is kind of practice of what does a log mean, and then also we're going to get some general rules. So here's the first little section, your problem number 2 in your notes if you're following along, which you should be. Okay, so log base 3 of 3. I'm going to say, what does this equal? So let's say, okay, so this is equal to x. That'll help me solve it. And then write it exponentially. Let's write this exponentially to see what this is. So what this means, remember I take the base, I raise it to this power, and I set it equal to this. So what this means is 3 to what power is equal to 3? Now, what is it? If you are thinking 1, you are correct, because 3 to the first power is equal to itself. Let's do the same thing with the log base 6 of 6. So the major point here is practicing how to do logarithms, how to write this. So this means that 6 raised to what power is equal to itself? So 6 to the x equals 6. It's 1, because 6 to the first power equals 1. Let's do another one. Log of 0.5, log base 0.5 of 0.5. I'll set it equal to x. So this means that 0.5 raised to what power is equal to 0.5? 0.5 to the x equals 0.5. Well, it is 1. How about this one? ln of e. Ooh, ln. Remember what that means? That means the natural log. And just for a little help here, I'm going to write out log base e of e equals x. So let's write this one exponentially. This means that e to the x equals e. E to the x equals e. Remember, e is it's a constant. It's like that number 2.71 blah 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 blah. It's Euler's number. It's the number like pi. It's an irrational number, keeps going. And e raised to the first power is equal to itself. Log of 10. Now you got to remember for this one, what is the base of this log? The base, the implied base is a 10. So I'm going to write a 10 right there. And this is saying 10 raised to the x is equal to 10. So 10 raised to what power is equal to 10? Well, again, it's 1. So hopefully you're seeing the pattern here. These are all 1s, and that leads us to a general rule. If you have log base b, and then you're taking the log of the same thing, so log base b of b is always going to be equal to 1, always and forever. So like that could be anything. I mean, we could get all crazy and throw like a log of pi squared of pi squared. Aw, snap, there's all kinds of crazy stuff going on, but check it out. If this and this are the same thing, it's just equal to 1, always and forever. All right, let's do another one. Let's do what happens when you take log with anything as the base, but we take it of 1. So if you are feeling kind of crazy here, why don't you press pause on the video and try to solve this first one yourself, okay? Or this first couple, all of them really, because you can do it. So press pause. All right, so welcome back. Let's practice how do you do this. So I'm going to say this equals x, and the major key today here is understanding what this means. So this means that 4 raised to the x is equal to 1. That's why some classes like to call it the circle of life. This means that 4 to the x power is equal to 1. Well, 4 raised to what power is equal to 1? If you are thinking 0, you are correct, because remember, anything to the 0 power is equal to 1. So the answer is 0. Okay, that's Christmas colors. Let's throw some blue in there. All right, same thing here. So this means that 7 to the x is equal to 1. 7 to the x is equal to 1. So 7 raised to what power is equal to 1? Well, again, check it out. 0, because anything to the 0 power is equal to 1. Let's do another one. Let's do 0.5 to the x is equal to 1. That's an arrow there. 0.5 raised to what power is equal to 1? Well, again, check it out. It's 0, because anything to the 0 power is equal to 1. Okay, ln. Oh, snap. It's an ln. What does that mean? Don't freak out. This means log base e of 1. And I'll put this equal to x. And then I'm going to say, okay, so this means that e raised to the x equals 1. E raised to the x equals 1. E, again, it's just a number. It's Euler's constant. And e to what power is equal to 1? 0. Last one, log of 1. What's the base here? What's the base? If you are thinking it is 10, you are correct. I'm going to put this as equal to x. And this question, what log base 10 of 1 is asking, it's saying 10 to what power is equal to 1? Because I start with a base, it's raised to this, and it's equal to 1. So that, again, is 0, because anything to the 0 is 1. Check out, what's the pattern, guys? Yep, you guessed it. The general rule is that if you are taking the log with any base of 1, it is always equal to 0, because that is basically saying b to the 0 is equal to 1. That's how I would rewrite this log exponentially. B to the 0 is equal to 1. So it could get as crazy as you want. I could be taking the log base, I don't know, let's just throw a big number in there, 2,000 of 1 equals 0 automatically, because it's saying that this number raised to 0 is equal to 1. Okay, let's do another rule. Now things are getting real crazy. So your logarithmic muscles are growing day by day here. So what I want you to do is press pause and see if you can solve these. Press pause in the video and then meet me back and we'll work it out. So do it. Don't just watch the video. 1, 2, 3, hit pause. And welcome back. Okay, so hopefully you've at least given a shot to solving these. And so a hint here is you put an x right here. And then this first one is asking 6 to what power is equal to 6 squared? 6 to what power is equal to 6 squared? Now you could actually work that out and say 6 squared is 36. 6 to what power is 36? Or check it out, these are both 6's. So guess what? X equals 2. X equals 2 here because 6 to the second power is equal to 6 to the second power. Now, how about this next one? 9 to what power, because I start with this one and I say 9 to this is equal to all of this. So 9 to what power is equal to 9 to the 1/2. Now again, you could go and say, what is 9 to the 1/2? Well, okay, let's see, 9 to the 1/2, remember that means, oh yeah, that's a rational thing. That means a square root of 9, so that is equal to 3. But you don't even need to do that. You can say, okay, so this is 9, so guess what? X is equal to 1/2. How about this one? This next one, we've got log base 2 of 2 to the 5th. I'm going to put it equal to x. I'm going to rewrite it exponentially, so a little circle of life here. 2 to the x equals 2 to the 5th. 2 to the x equals 2 to the 5th. Now again, you could say 2 to the 5th is 32. 2 to what power is 32? But why do that? Check it out. Same bases. Exponents are equal. Guess what x is? X equals 5. And last one, ln. Ooh. ln. Now, in this one, I've been setting them all equal to x, but check it out. This one has an x in the problem, so I'm going to use a different variable. I'm going to say, I don't know. How about, let's get creative. Y. Okay, now remember what ln means. ln means log base e of e to the x is equal to y. So there's lots of letters here, no numbers. But what this means e raised to what power is equal to e to the x. E raised to what power, the y, equals e to the x. So check it out. E, x, y, x is equal to y. Hopefully you guys are noticing a pattern in this one. Check it out. When you have a base, here, that's the same as something being raised to the power, what does it always equal? Well, look, this one, the 6's were the same, and then 2 is our answer. In this one, 9 is the same, and then what's our answer? 1/2. This one, 2 is same as 2, and the answer was 5. And this one, e, technically our base, is the same as the e here, and then our answer is x. That's our answer. So here's the general pattern. In general, if you have log base b of that same b raised to a power, it's always equal to just the power. That's it. It's just equal to x. So again, log, I don't know, let's say of 15, of log base 15 of 15 to the x squared minus 4x plus 7. Oh boy, that looks wild. But guess what happens? The base is the same as the base of something being raised to a power, so it's just equal to the exponent, x squared minus 4x plus 7. Okay, let's do the last, this is the last general rule we're going to do, and this one's a little tricky. It's a little tricky. What happens when you, and these are 3 different problems, so I'm just going to kind of go like this. Okay, so what happens when you have a number that's raised to a log. And notice, if you're noticing what pattern you're thinking I'm going to be doing, notice that the number here is the same as the base. 64 is my number and 64 is the base of the log. 4 is my number here and 4 is the base of the log. So, and the question is, what happens when you raise a number to a log with the same base? So let's do this first. Let's first evaluate what is log base 4 of 16. What is this? So let's first do this. So log base 4 of 16. So I'm going to set it equal to whatever, x, question mark, what have you. And then I'm going to rewrite it exponentially. So remember what this means? This means that 4 raised to what power is equal to 16. So 4 to what power is equal to 16. You should be thinking that x is 2 because 4 squared is equal to 16. So x equals 2. So what this means that log base 4 of 16 is equal to 2. What this really is, this is 2. So what I'm doing when I am doing 4 raised to the log, it's okay, Ursa, we're just doing logarithms. Log base 4 of 16. What this really is, this is really 4 to the 2. And what's 4 squared? Well, 16. Interesting. Okay, let's do the other one. Let's do this next one. So we've got 3 raised to the log base 3 of 1/9. So again, let's first figure out what this exponent is equal to. So let's go down here and let's do what is log base 3 of 1/9. We're going to do the exponent first. So I'll put this equal to, I'll just do a question mark this time. Okay, so this means that 3 to what power? 3 to what power is equal to 1/9. Now, this is a little review here. I know that 3 squared gives me 9, but what power, so 2 would be the answer if it was just 9, but what do you do to an exponent to make something go in the denominator? Or as we said in class, throw them in the basement. How does that happen? It's a negative exponent. So what this is 3 to the negative 2 is equal to 1/9. And because 3 squared equals 9, and then the negative up there makes it go down in the denominator. So this exponent here is -2. Okay, so this whole thing right here is equal to -2. So now if I'm going to do 3 raised to the power of log base 3 of 1/9, this really means 3 to the power of, remember we found out that log base 3 of 1/9 is actually equal to -2. So this is really 3 to the -2. And then what's 3 to the -2? Well, because it's a negative exponent, it means it goes in the denominator with a 1 over it. And then squared, 3 squared is 9. So the answer is 9. Well, 1/9. Interesting. The answer here was 1/9. The answer here was 16. What's the pattern? If you are thinking that when you have a number raised to a log with a base of the same number, these cancel out and you're left with just what it is. Check it out. These kind of cancel out and you're left with 16. Let's do a 64. Let's do a 64 to the log base 64 of 8. So what do you think the answer is? Let's see if you're right. Okay, so first we're going to evaluate the exponent. So let's see, what is log base 64 of 8? So I'm going to set it equal to a question mark. What this means is 64 raised to what power is equal to 8? Okay, you got to remember here, I'll give you a hint up here. The square root of 64 is equal to 8. Because some of these exponents, guys, are going to be coming back. Like, then you got to know that a negative exponent means that it goes down in the denominator. And you got to remember, so I know the square root of 64 is equal to 8. So what power is that? Anybody remember? Technically, there's a little 2 here. There's a little 1 here. So technically, 64 to the 1/2 is equal to 8. So remember, if you're taking square root, the power of that is 1/2. If you're taking cube root, the power of that would be 1/3, et cetera, et cetera, et cetera. Here's the whole point. 64 raised to what power equals 8? 1/2. So what is this whole thing equal to? 1/2. So if I'm trying to do 64 raised to the power of the log base 64 of 8, that's really doing 64 to this whole thing's equal to 1/2, so the 1/2 power. What's 64 to the 1/2? That means the square root of 64. What's the square root of 64? 8. So the answer is 8. Check it out again though. I have a number. It's raised to the power of a log with that base. What happens? You just get this number. So let's make a general rule here so that you don't have to always evaluate it out every time like we did. General rule, if you have a number raised to a log with the same base of something, of c, so b raised to log base b of c, the answer, if you evaluate this out, is c. Or you can think about it like this. This and the base and the log base b cancel each other out and you're just left with c. So I could get as crazy as I want. I'm going to do an e1. How about this? E raised to the ln of, I don't know, 3x squared minus 7x plus 2. That looks like a really scary problem until you remember that ln is really just log base e. And if I have e raised to a log base e, cancels out, and I'm just left with 3x squared minus 7x plus 2. Okay, let's do some examples here. So examples, these are kind of your homework problems. So we're going to do a couple, and then you're going to do a couple. So for number 10 and 11 and 12 and 13, the problem is to rewrite each equation in exponential form. So there's no evaluating here. All you're doing is you're changing a log into an exponential form. So here you go. Log base 5 of 625 equals 4. So 5 to the 4th equals 625. 5 to the 4th equals 625. And when you're given numbers with these, like if this was a test or quiz, and you're actually given numbers, you could check that that's true. Like let's say you got confused and you said like, oh, this means that, I don't know, I think it means that 4 to the 5th equals 625. You could check on your calculator and you would find that 4 to the 5th does not equal 625. So that's not the right answer. This is the right answer, and you could check that. Okay, number 11, moving on. Log, no base, of 1 over 1,000 equals -3. So this is where you have to remember, what is the base here? What is the base? If you're thinking 10, you are correct. Now, you have to rewrite this exponentially. So this means that 10 raised to the -3 equals 1 over 1,000. 10 to the -3 equals 1 over 1,000. Again, that negative exponent's coming back. Remember, the negative means it throws it in the basement, and then 10 to the 3rd is 1,000. So that's where that comes from. But this is our answer. All right, now go ahead. You do 12 and 13, and I'm going to meet you up with 14. Here we go, number 14. Now you have to write each equation as a log. So you have to write each equation as a log. So let's see. Ooh, oh boy. Okay, so the base is always the number that's being raised to a power. So I know right away this is log base 7, log base 7. And remember, the exponent is the answer. So the answer is going to be 3. And then if 7 to the 3rd equals 343, then this means log base 7 of 343. So log base 7 of 343. And you can check and see. This is saying, with this statement right here, I'm saying that 7 to the 3rd power equals 343, which is exactly what we started with. So the problem of this was to write it in logarithmic form. Here we go. This is the logarithmic form. Let's try this one. Number 15. We've got 16 raised to the 0 equals 1. So what's the base of the log going to be? If you were thinking 16, you are correct, because that's the thing being raised to a power. So log base 16, little 16, and then the exponent is always the answer. So it equals 0, and the thing that this is equal to is what's inside the log. So it's log base 16 of 1 equals 0. Again, let's check it. What we're saying is that 16 raised to the 0 is equal to 1. And that's exactly what we started with. So this is my answer. Log base 16 of 1 equals 0. All right, you try 16 and 17. Follow the exact same pattern. Remember, the base, the number that's being raised to something, is the little base. The exponent is the answer. And then the thing that it equals is what's inside the log. Go for it. Okay, now we're going to actually evaluate some of these. So let's actually evaluate some of these. Log base 2 of 16. So we're going to evaluate it, but the way we're going to do it is we're going to rewrite it exponentially. Oh, right, interesting. W-R-I-T-E. Okay, so we're going to write it exponentially. So here's what I suggest we do. Let's put it equal to either x or question mark, whatever you want to do. Okay, so then rewrite it exponentially. So this means that 2 raised to the x equals 16. So 2 to what power equals 16? Let's see, 2 squared is 4, 2 cubed is 8, 2 to the 4th is going to be 16. So the answer is 4, because 2 to the 4th power equals 16. Number 19, ln base e. Oh, sorry, I just gave it away. I was about to say, what's the base of ln? Oh my goodness, this is log base e of e squared. Now, you automatically know we have a rule for this, right? The rule is if you have a base and then this is being raised to the power, you already know the answer is 2. So the answer is 2. But if we were going to write this exponentially, I'd say equals x. And then I'd say, okay, this means that the base here is e. So e to what power equals e squared? Oh my goodness, x and 2. So the answer is 2. Let's do. All right, guys. So here's what I want you to do now. I want you to finish through number 25. We will finish the rest in class together as a little review. So you've got just a couple problems. Give it your best shot. Remember, the key for all of these is I want you to write them exponentially. So these are logarithms that you're trying to evaluate. I want you to write them exponentially. So what that means is you're going to set it equal to x or question mark and write it exponentially. So you are finishing through number 25 on your sheet, and then you're going to upload it to turnitin.com tonight, okay? You guys are doing an amazing job. We will keep practicing this. Keep up the good work.